Okay, so let's start understanding exponents a little bit more. We're going to start with just the basics. If you have, so these would be the properties. If you have an exponent times another exponent, that they have the same base. Okay, so their variables up here just is that saying that the exponents are different on them. But this, the number on the bottom, is the same. Then you can combine them by taking and adding their powers. Okay. Now first, a basic example of this is that if you have, for instance, do a variable instead of a number because that helps kind of see. So if I have x to the third times x to the second, this is the same thing essentially that this x to the third means x times x times x, and x squared means x times x. So this has 5 x's now, so this would be x to the 5th. Well, if you look at this, this is also the same thing as doing x to the 3 plus 2 equals 5. And that's why you add the exponents instead of multiplying. Now remember that if you are have numbers in front of those numbers still follow the rules of regular multiplication. So for instance, if we have 3x to the second times 5x to the fourth, then you will be multiplying the 3 times the 5, and you will be taking your exponents of x and adding them together. So you have to keep those two things straight. So then here you'll have 15x to the 6th power. Okay? So you add the exponents when you're moving them, when you're multiplying them. Okay? So that's the multiplication. The next one that we'll talk about is doing when there's parentheses. So for instance, if I have a number or a variable and I have parentheses around it, there's an exponent and then there's another exponent outside. In this case, you would multiply and you would do x times y. Okay, so an example of that might be to do m to the third raised to the 5th power would be m to the 15th power. Okay, now what happens when there's variables in there, or there's constants in there? So if I have 3m cubed to the 2nd power, okay, this has to distribute to everything in the parentheses. So this would become 3 squared times m to the 6th, because you're multiplying them because it's outside the parentheses. And 3 squared is 9, so you would get a 9m to the 6th. Okay, so it's distributing into each of those, but if you do m to the 3rd raised to the 2nd power gives you m to the 6th, and this 3 would then just take the squared. Okay, now if this is like this, m to the 2nd raised to the 5th power, then in this case the 3 would not need to be multiplied by or raised to the 5th power. It would just be 3m to the 10th power. Okay, so as we do this, just make sure there's little things that you just have to get used to and make sure you get this down so that the next assignment you don't get confused between the two. Okay, the next thing is if you're dividing. So if I have the same base again and I have them divided by each other, then you will be taking the base number and you can subtract the exponents. Now remember, you have to take the top exponent minus the bottom exponent. Okay, so for example, I could have x to the 5th over x to the 3rd, and I could rewrite this as x to the 5 minus 3, which would give me x to the 2nd. Okay, so now if I have x to the 2nd, then here I can also go through and what happens if it's switched? If I actually go the other direction, let me show you. So remember that we have to take the top minus the bottom. So this one would be x raised to the 3 minus 5. So this would give us x to the negative 2. Okay, which brings us perfectly into our next property. So if something is raised to a negative power, what does this actually mean? Well, because you do need to write your answers in positive exponents. So to make this a positive exponent, it means that it is in the denominator of the function. So this would be 1 over x squared. Okay, so let's try if I do b to the negative x equals 1 over b to the x. And the same thing, if I have 1 over b to the negative x, I can rewrite it as b to the x in the numerator. So it would just be where things are. So if I have, for instance, let's say x cubed, y to the negative 2, m to the second, n to the negative 5. Okay? So we are going here and we're going to make it so that everything is positive. So we have x cubed stays there because it's already positive, right? And the m squared is going to stay there because it's already positive. Well, if I want to make this n to the negative 5th positive, if I move it to the numerator, I can change the exponent to a positive number. And the same here, this y can be changed to a positive y squared in the denominator. Okay, so moving it up and down on the pods to the numerator and the denominator, that's what will make it positive or negative. Okay, another property that you should know, but that hopefully we'll just reiterate, is if anything raised to the 0 power equals 1. So for example, if I have, let's just do x to the 0 power equals 1. Or 217 to the 0 power equals 1. Okay, so it doesn't matter if they're numbers or variables. Those will always equal 1 if they're raised to the 0 power. Okay, so the other thing that this assignment is going to get into is having exponents that are fractions. So for instance, if I have 3m to the 3/2 times 3m. Don't let the fractions throw you off. You guys know how to add fractions and subtract fractions, so you just treat it that same way. So first of all, we take our 3's and we multiply them together to give us 9. Then we're going to have m raised to the 3/2 plus 1. Okay, so to do that, we're going to have to make the common denominator. So we'll have 3/2 plus 2/2, which will give us 9m to the 5/2. Okay, so don't let those exponents throw you off when they are fractions. Let's see if there's anything else. Okay, it looks like the one last thing that I want to make sure is if you have a negative exponent, don't let that throw you off either. So for instance, if I have 5x to the negative 2 times 3x to the 5. Then when you go through, make sure that you still, we did this a little bit over here. Another example that would be harder, let's do, instead of this, what I'm more trying to cover is let's do through, let's see, 10x to the negative 1 power. Okay, so this, we would still divide our constants out in front, so we would still have 1/2, and then we would have x to the negative 2 minus a negative 1. Okay, so make sure that if you are subtracting exponents for a fraction and there's a negative exponent, that you are still doing a negative. I don't think that there's many in this assignment, but there will be in the next, and so I just wanted to make sure we cover that. So we have x to the negative 2 plus 1, which will give us negative 1, which means to make that positive, we need to make the x go into the denominator. Actually, you might have one like this on there. And so you would have 1 over 2x, where this one you can see is on the numerator, and so that would have to be for 2x. Okay.